Now, let's talk about the sum of n terms in a geometric series and the infinite geometric series. So, the sum of n terms of a geometric series can be found by two formulas. This formula is for the case where the absolute value of r, the common ratio, is less than 1, and this formula is applied when the absolute value of r is greater than 1. So Sn, being the sum of n terms, is equal to a1, which is the first term of the geometric series, into 1 minus r, the common ratio, to the power n, which is the term number. So for example, if you want to find the sum of three terms, the value of n would be 3. And this is all divided by 1 minus the common ratio. This is for the case if the absolute value of the common ratio is less than 1. And if the value of the common ratio, the absolute value, is greater than 1, well, we'll have this formula. The only difference between this formula and this formula is in these terms. As you can see, when the absolute value of r is less than 1, this term is equal to 1 minus r to the power n over 1 minus r. And in the case where the absolute value of r is greater than 1, this becomes r to the power n minus 1 over r minus 1. So basically you're just exchanging the positions of 1 and r to the power n and 1 and r. Now, for the case of the infinite geometric series, so that is basically a geometric series which has an infinite number of terms, and so we have to find the sum of those terms. And now you can see that, just by using common sense, that you can only find this if the absolute value of r is less than 1. Why? Because if the absolute value of the common ratio is greater than 1, that means each consecutive term in the series is becoming bigger. And the value of the infinite geometric series would just be infinity, because the values are getting greater and greater. So if it goes to infinity, that's just infinity. So the sum of the infinite geometric series, obviously the absolute value of r is less than 1, that you can find by this. The first term a1 divided by 1 minus r, r being the common ratio.